In the previous video you saw a mock-up of one side of the Z column and the X. Well, the X is obviously still attached. Today we're going to put the other side of the X rail on, put the gantry up, so we'll have the two columns for the Z axis and the Y axis connected there. I think I've got most of the parts we need for that, but let's see how far we get before we run into a little engineering issue. I'm doing practical engineering here, so not everything was designed beforehand. I'm designing as I go, partly because, as always here, I'm doing this on a budget and I'm trying to see how I can do this with the parts and the resources I've got at hand. In the end, this is a fairly expensive project. I'm trying to use fasteners and things like that I have laying around, but overall, yeah, this isn't for the faint-hearted. This is a couple of €1,000 project, fairly expensive for what I want to do with it, but I think worth it for what we are going to be able to accomplish once this machine is done. So let's start with the parts. So first part we need, so let's go back to the table so it's easier to actually show you, because 20mm round steel bars are kind of heavy. This is one of the columns that you saw last time, actually the one we didn't use last time. We're going to be mounting that on, for the viewers, the right side of the table. We'll be adjusting that in a minute. You can see here already that I've got several 3D printed parts. In this case I made them yellow because I happen to have a lot of yellow filament. I use that to hold the 2020 aluminum extrusions together and mount the mounting blocks for the linear rail. Also, there's a big 3D print here, big block, and that's what connects the bearing blocks on the linear rail with the Y-axis linear rails. Very heavy print, made that really solid. Just like with the other projects we do, all the CAD files for these different elements I'll make sure to put on our GitHub, or if you have a preference for a 3D printing platform that you'd like us to place the files on, let us know in the comments and we'll see what we can do there. But the link will be in the description of the video and you can download all these files for yourself. Some of them are very specific to what we're building here. Others I think are very generic and you might be able to use in your own project. So as I showed you earlier, the left side rail for the X-axis is already in. The right side rails for the X-axis are actually sitting here. I want to put those in next, so we have both of the carriages ready to go and we can then build our gantry on top of that. So attaching this rail to the table, it would be obvious to put that in the holes that are already there, except those holes are 2 inches apart and the rail has 50mm center on center. So 2 inches is 50.8mm, so that won't work. It will actually run out of space very quickly. And the other problem is the rail is drilled for 5mm screws, while the table is drilled for 6mm screws. And the 5mm actually fit perfectly in the hole, and the head won't fit. So I guess we're drilling new holes. Obviously I figured that out when I mounted the other one. So immediately I also moved it out to the outside a little bit to gain a little bit more space on the middle that we can actually use while we're using the machine. So let's align the rail 15mm from the side, put that straight, and then start drilling some holes. So I aligned it roughly at 15mm from the edge. Really the only part that's important is that this first drill hole is going to be there. I'm going to drill that hole, tap it, and put a bolt in lightly. So that will be my rotation point, and then I'll keep going down the line. I'm assuming this rail's pretty straight, but you know what they say when you assume things, so let's just measure every couple of holes, drill that, tap it, and then go for the next, and then I can adjust it a little bit as we go. So I've got 3 tools I'm going to be using for this, obviously with a drill. First, I've got a 5mm drill that fits tightly in the hole that's already in the linear rail, and that will center my hole. Then I've got a starter. I'll change over, I'll move the rail out of the way, and I'll change to the, I think it's 4.2mm, but that's the drill size for the next step, and that's the tap to actually tap the hole so I can put a bolt in. Well, that should be enough. Let's see. Yep, there's actually quite a nice little drill starter here. Then I'm changing over to my smaller size drill. This is actually the tap size drill for this M5 hole, and drilling that hole next. Well, that's the hole through and through. So next step is to put a tap in there. And I like living dangerously, so let's see if we can tap it with the drill. I'll put a little bit of slip on, so we at least have a chance of it surviving. So let's see what it does. So if you haven't done that before, maybe you noticed I did a little bit in, out, just to get the debris out and make sure the tap hole actually worked out. So that should be it. So it's an M5 by 20 bolt. And it doesn't have to go in all the way, right? It's just a pivot point, so attached is attached. Well, there we go. First bolt is in. Let's drill the other holes. Well, that's the last one in. I'll have to make something extra here, an end stop that has the end stop switch in it, and also just a physical stop so the carriage doesn't run off the table. This is also the site that the motors are going to be at, but that's for way down the line. For now, all the bolts are in, every sixth one, very sturdily mounted. So let's put the distance bar on the carriages so we can start mounting the gantry. So let me get the spreader bar. So here's the distance bar. I drilled holes here at specific intervals, so the distance is the same as on that side. So the left and the right side will be exactly the same distance. I did that on the mill. You haven't seen that yet, but besides this workspace, we have a small metal workspace with a lathe and a mill. Also attached the corner angles, just like that side, just to be able to mount the gantry, the uprights too. So it attaches with 4 M5 bolts. They're the same M5 by 20 that I used to put the linear rails on the table. Nice to have the same bolts. Makes service so much easier, but also makes it much cheaper because you can just buy bolts in bulk and then reuse those. And bolts in bulk are a lot cheaper than individual ones. And what you may notice on the video here in detail, I milled out the head very precisely. That helps align it to within, I don't know, sub a tenth of a millimeter, pretty close, and we'll be able to do tuning later on to make sure that the electronics know what the actual match is. So now both sides of the table, the x-axis, but both sides of the table have the same distance and have the carriage that runs through and parallel to each other, at least within a couple of tenths of a millimeter, and that's fine for what we're trying to achieve here. So on this side of the table, there's the ball screw that actually attaches the motor on this side and makes the whole thing move. So that's the next thing we're going to attach on the other side. This is the side with the threads and the longer machine surface that the motor goes on. So that's on this side of the table. So they're both on the same side. And here on the back side is just the pillow block with the snap ring to retain it. So let's see what we can put together. I just found that I'm missing bolts. I don't have bolts that are long enough, so I need to go get those. But for now, I've got some thumb knobs that will work fine for attaching it, so we can at least keep going. So while the other side just has a retaining ring, this side where the motor goes actually has a much larger pillow block. Slides on, and then there's threads exposed, and there's actually a nut with a retaining screw that goes on this side. So let's put that on, so at least we have the spacing right. And then sure, there's some specific Newton of preload to go on here. We'll look that up before we finally attach it. By now finger tight is plenty good enough. So we slide that part in the bearing block. So pillow block here, it's attached there. I can hold it in the right place. drill a hole just as a starter. So this is a 6mm hole that fits right in there in the pillow block. And let's make sure everything is tight. So that's the left side ball screw also mounted. So we have ball screws left, right now. Carriages on the top. Now we need a carriage on the bottom. So we have a horizontal and a vertical linear guide. And that'll make the carriage sides really, really stable. So the vertical linear rails are actually exactly the same as the horizontal linear rails. So 20mm ground flat bar with 2 carriage blocks on top. These ones were mounted to the side of the table, and while the positioning of the guide on the top, the horizontal guides, had to be somewhat precise, the ones here actually don't matter that much because it will be a sliding fit. We'll just attach them wherever they are. So they have to be parallel with the rest of the table, but it doesn't really matter if they're a little bit off from one side to the next. So this is where we're going to be mounting the linear rail, just below the pillow block for the ball screw. You can see it's got free movement. We did put a little bit of a spacer with some tape in there. So let me drill a hole. Let's attach the rail on this side and then drill the other side. I'm going to connect the connecting block to the ball screw nut, so it slides along. This is where the x-axis actually attaches to the ball screw. And I did make sure when I attached it that the blocks, the slider blocks on the linear rails are on either side of the rail block because they can't go past, they're stuck. The nut on the ball screw is captured between the linear rails. For the gantry and the y-axis, first thing we're installing is these 3D printed blocks. They're really simple. And what they're for is to attach to the vertical linear rails, and it fits the 2020 profile, so we can make that linear rail go up. So an important thing to know, right? These are pretty small heads, so there's a lot of pressure on a small part of the 3D printed part. Tight is tight. There's no pressure on these pulling it out. So don't over tighten those bolts. It just has to be on. It doesn't have to be tight. One thing I always do instinctively is tighten bolts diagonally. For this, it probably doesn't matter, but you know what? It doesn't hurt. Obviously, for putting engines together and things like that, that's very important. That's why I picked that up. But it does help you distribute the torque just that much better and make sure the part is straighter and tighter. So one additional element I built in is a cage in here for a M5 nut with a bolt from the outside, so I can tighten the 20mm square aluminum extrusion into the hole. It still slides in, but I can now tighten it with the M5 bolt. And because it's pulling against the 3D print and threaded into the nut, it's actually really tight and you can actually put some torque on there. In the last video, you saw that one side of the gantry mill was already up, right? One of the Y side, because I was testing how it would fit. And I found out that my aluminum extrusions are a little shorter than the height I want to get, which is fine. I connect them with a 3D printed part. Well, last time the wrong part was on there. It was a shorter part. Now I 3D printed the right part. So I'm going to be prepping the 3D printed parts. Got some holes that need cleaned up, some bolts that need to be pressed in, and then we'll be installing those. So we need 4 of these connector pieces. They're actually two-sided. So you can see there's 2 lefts, 2 rights. 1 left, 1 right for either side. I just 3D printed these, so they need a little bit of cleanup, so I'm going to be drilling out the holes, then pressing in some linear bolts to connect it to the linear rails for the Z-axis. So we're replacing the small yellow part here with the bigger 3D print, the gray part. It will be attached like this and then attached to the linear rail the same as it's currently attached to the yellow block. So let me take the yellow block off, then we'll install the new one. As you can see, same torch attachment point, but slightly bigger. So for now we'll tighten these down. Later on we'll use these to adjust the vertical so that the columns are perfectly vertical from the different attachment points, but for now they're just attached so the whole thing doesn't fall down. So that's the first column of the Z-axis together, and while all the parts are very lightweight, together it's actually fairly strong. I mean, there's still some movement in there, but rotationally it's very strong, and side to side it's very strong, and it now slides very solidly. So let's put the other side together. So before I put the support plate in, I'm going to put the top spreader bar in because I've got a little bit of play now, and once I put the 3D printed part in, it gets pretty stiff. So I'm using these angle pieces to connect those. So let's do that next. So that's both sides of the Z-axis together, and they slide really nicely. Obviously that's not attached to the ball screws yet. So next I'm going to attach the Y-axis linear rails. To finish the mechanical installation of the Z-axis, I want to connect the columns to each other. I mean, they're pretty sturdy, but having a cross brace and then some bracing in there will make them that much stronger. So let's get to it. So there's obviously the corner bracing that's already there. That's how all the three sides connect to each other at the corners. And I'm adding 3D printed bracing, both on the front, the back, and the top, to really make it sturdy. So that's the final bracing for the gantry. It's much sturdier now. My analysis shows that it's up to 5 times stronger, maybe even better than that, so pretty good. We've obviously got the x-axis, the y-axis with 4 linear rails, and the z-axis. That's all we've got time for this episode. Mechanically, it's mostly together. Off camera, I'll put some of the extra bolts in and align everything. And then next episode, we'll be mounting all the ball screws and the motors. So if you want to know what all of this costs, watch this series all the way to the end, and there we will tell you exactly what the build budget was. Join me as we build our own open source hypercar. Follow, subscribe, comment, like, anything, or even better, share with your friends. It really helps us out.